Hello, how are you doing? This is Mike, and in this video we are going to talk about the conversion of the standard form of a quadratic, and I abbreviate quadratic with the term quad, to the complete square form. I want to let you know that I do this very differently than a lot of people. I don't see the most common way of transforming this. I see it in a different venue. So I will tell you that I am not consistent with a lot of your instructors out there, but that might help spur a different way to navigate how to convert these problems. So as we said before with some of our examples, it's important for us to first recognize some patterns. So I always like to recognize some patterns before I go and discuss how to convert to a complete square. Let's say I give you x minus 1 squared, x plus 1 squared, let's say x minus 2 squared, x plus 2 squared, and let's jump down to x minus 5 squared and x plus 5 squared. And I were to ask you to FOIL each one of these binomials out. So I'm assuming at this level this shouldn't be that bad now, so I'm going to do it rapidly. We're going to have x squared minus 2x plus 1. This will give us x squared plus 2x plus 1. This will give me x squared minus 4x plus 4. And this is x squared plus 4x plus 4. This will be x squared minus 10x plus 25. And this is x squared plus 10x plus 25. So let's see if we can recognize a pattern. And sometimes these patterns are not as easy to see, but hopefully we can recognize them. So notice here, all of my last terms are all positive, which definitely helps to get an idea of what happens. So if we look at these last terms here, negative 1, positive 1, negative 2, positive 2, negative 1 squared is positive 1. Positive 1 squared is positive 1. Negative 2 squared is positive 4. Positive 2 squared is positive 4. Negative 5 squared is positive 25. And positive 5 squared is positive 25. So I recognize if I want to get from this term to this term, I recognize I will always square. I will always square that value. And let's think about the next portion. If I want to see a relationship, let's see if I see a relationship here. Notice negative 2 divided by 2 gives you negative 1. Positive 2 divided by 2 gives you positive 1. Negative 4 divided by negative 2, divided by 2 gives you negative 2. Let's jump down to negative 10. Negative 10 divided by 2 gives you negative 5. So hopefully we can see some relationships between the completed FOIL terms and those complete squares. And these are actually called a complete square form. So that's the complete square form. So let's say in this next example, determine the constant that would need to be added to have a complete square. So let's say I had x squared minus 6x. What would that constant have to be such that you had a perfect square or a complete square? So let's think. Okay, I know that in my relationships, if I wanted to go back to this perfect square, complete square form, I know I would divide this middle number by 2. So I recognize this would be broken down into something squared. Bring my first term down. I know that has to be an x. And we said this value would have to be divided by 2. So I know my perfect square, my complete square, is in fact a negative 3. And I can check that by FOILing. So I will have x minus 3 times x minus 3. X times x gives me x squared. X times negative 3 is minus 3x. Minus 3 times x is minus 3x. Minus 3 times minus 3 is a value of positive 9. So I have x squared, check, x squared. minus 6x, check, minus 6x. And last, I would have to have this plus 9. So I recognize I would have to add a plus 9 on the end. Let's do the same thing again for the next example. Let's do the same thing again for the next example. Let's say I gave you x squared minus 16x. What would be that constant I would have to have at the end such that I would have a perfect square? Hopefully you recognize this we broke out into something squared. My first term would be just that value of x. This term I would divide by 2, so I would get negative 8. And most of you now are recognizing that if I square negative 8, I'm going to get that value of positive 64. So I would have to add positive 64 in order to have that perfect square. Because x minus 8 quantity squared is in fact x squared minus 16x plus 64. Let's try another example. Let us try another example. Let us say I gave you x squared minus 5x. Now let's do plus 5x. X squared plus 5x. What would be that constant we would have to add on this side, or what would that constant be that we'd have to add in order to have a perfect square? Hopefully we recognize that this will be something quantity squared. My first term is going to be a value of x. I'm going to have to take this value and divide it by 2. And positive 5 divided by 2 gives you a value of positive 5 halves. Next, if I want to determine this extra value, this constant, I would take this value and I would square it. So 5 halves squared really is 5 halves times 5 halves, which gives me 25/4. So we can work with fractions. So I'd have to have a positive 25/4 there, and that would give us x plus 5 halves squared. It's imperative for us to recognize these patterns because as we determine the method to converting a quadratic in standard form to a complete square, this will be extremely helpful and expeditious.